Time to break out the highlighter for the quotient rule. So if you are dividing two functions, and again, just like we did with the product rule, I'm going to color code. We have a function in our numerator and a function in our denominator. What happens? Well, we keep the second one the same, and the order matters with the quotient rule. We keep the second one the same, multiply by the derivative of the first one. And then like the product rule, we add or subtract. In the product rule, we add. In the quotient rule, we subtract. Then we keep the first one the same, derivative of the second one, divided by the second one squared. Same thing could be shown in Leibniz notation. We have our first function and our second function. We keep our second function the same, multiplied by the derivative of the first, minus keep the first function the same, multiplied by the derivative of the second, over the second squared. Again, this is on your formula sheet. Okay? I believe only the Leibniz notation is on your formula sheet. If you can memorize it, it helps you because you're going to be working with it often. Okay? So, and of the two, the product rule and the quotient rule, you have this idea of keep one the same, multiply by the derivative of the other one. Product rule is adding, quotient rule is subtracting. With the quotient rule, it's important that whatever function is in your denominator, that's the one you keep same first. So with the product rule, it doesn't matter the order. You could keep one the same, derivative of the second. It doesn't matter the order. With the quotient rule, you have to remember that it's the second one or the bottom one that stays the same first. When I was in university, they taught me that with the product rule, keep the second one the same first, just so that it's the same in the quotient rule. So if you're always doing the second one the same first, then you never forgot. Okay? Moving forward, I think it's just easier to focus on the quotient rule. Because if you screw up which one's same first in the product rule, it actually doesn't matter. It's still right. But with the quotient rule, it's really important that whatever function's in your denominator, that one stays the same first. And then as far as doing questions with the quotient rule, you just have to apply the formula. That'd be nice if you had to describe it in words. Simply stated, the derivative of the quotient is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the square of the denominator. I think that that statement is worthwhile highlighting this part. I don't know how simply stated that is. If you told a friend not in calculus, this is the quotient rule and I'm going to simply state it for you and read that to them, I don't think they would think you're saying something simply. Color coding time. We've got our derivative on the top, our function on the top and our function on the bottom. We're going to use our quotient rule. So I'm going to let you write the first step. I want you to plug everything into the formula. Check how you did. I'm gonna color code because it's so much fun. So the color-coded ones are where things stayed the same, and then beside them are derivatives of the other one. And if you did want to simplify it, that's what you would get. Just multiplying out the tops, combining your like terms. But for the most part, you wouldn't have to. You'd be fine just leaving it as that second step. Yes? If you, in this situation, like you're asking if you can write dy dx, okay? Not bad to then, because there's no y in this question anywhere. So it's not bad then just to say let y equal x cubed over 3x minus 7. Okay? Technically, what would make the notation best here is that this is saying find d dx says find the derivative of what's inside. So technically, the best notation that I would have on the left-hand side would be d dx of x cubed over 3x minus 7 written over and over again, which is tedious, right? But if you say let y equals, then you can use dy dx. I will tell you that if I ask a question in this notation and on a quiz or test you just write dy dx, I will not deduct for a notation error. I know in the grade 12 pre-calculus exam, remember those E errors, right? There is an E3 for introducing a variable that wasn't there originally. So this technically, by writing dy dx, there's no y's in the question, so you haven't defined it. So properly, you would say, let y equals, and then you could use dy dx. You could let g of x equals and then do g prime of x if you wanted to. You could introduce all sorts of different variables. So our next two equations, example 2 and example 3, are just practicing plugging things into your new formula. So I'll let you do that for example 2 and example 3. I'll put the answers up in a bit. Whoa. All right, so let's see how you did. Yes. If it ends up being the same thing, it's going to be fine. Like how I'll come check.
No, I typed it the wrong way, and I just switched the signs.
Yeah, it means the same thing. Yeah, so if he screwed up and wrote them the wrong way, realized it, so he changed the second one to a plus sign, the first one to a minus sign. It does mean the same thing. It's better if you don't screw up, but that's usually the case with a lot of things. No, then just leave it. Yeah. Like, and especially in the next one, which you did, it says specifically, do not simplify. How did you do? right, good. Whew. I want to do some advanced combination ones, but we'll just, maybe at the end. What it looks like when you put a product rule and a quotient rule together in the same one. Yeah? Okay, we'll leave that for the end. Find the gradient of a tangent at x equals -1. So we introduce a new derivative rule, and then we just do the same questions with the new rule. So how many times have we seen questions like this? Lots, right? What do? We find our derivative. Well, what's our derivative this time? And now we have to use a quotient rule to find our derivative. Then to find it when x equals -1, plug in -1. So I've simplified it a little bit first. You wouldn't have to simplify. If you wanted to plug in -1 right at the beginning, you could have. Plug in -1. Simplifies all the way down to 1. So if you get to the video later, you can check these out. You can pause it on the video. There's the answer for 5. Here's 5b with a smile face. Look at that. And finally, here are the answers to the review questions